So you may have noticed in the previous exercises that we had a lot of duplication of our code. We had to write the same method several times. We can use inheritance in Ruby to simplify this code. So remember that objects in Ruby are designed to model or represent real life. Inheritance allows us to extend that representation further. Firstly, two concepts. An object's ancestors describe the more general case. An object's children describe the more specific case. Let's try to understand what that means. So a car is of type vehicle. A bus is also of type vehicle. The vehicle is the more general case, it's the ancestor. Bus and car are the children of vehicle. They're the more specific cases. So we can also say vehicle is the parent of car and bus. So think about this for a moment. What are the common traits of car and bus? What are the differences? Firstly, you might say a bus quite often has more than 4 wheels. It might have 6 wheels. Or it might have an articulated door, for example, or a ticket machine. A car might take regular fuel, a bus might take diesel. And yet they have many similarities. They both drive on the road. They both have a driver. They both have turn signals and brake lights. Let's take a look at another example. We can say that apple is a kind of fruit. We can also say a pear is a kind of fruit. You can go even further than this. Fruit is a kind of plant. Plant is a kind of living thing, and a living thing is just a kind of thing. In Ruby, we call thing object. So how does Ruby use this idea? Inheritance in Ruby uses the idea of a subclass. Let's create a person class. Person class has 2 attributes. Using attree-accessor, we can define name and email. However, a student is a particular kind of person. So we can create a class student that extends person. So the student class gets all of the attributes that we defined in person, but in addition we're defining an attribute that is specific to a student. In this case, the student number. So now when we create a student class and assign it to a variable called person, we get the name of the person in the same way that we did on the person class, but now we also have a student number attribute. This means that if we have common code, say methods or attributes, they can go in the parent class. We only put in the child class the attributes and methods that are specific to that class. It's also possible to extend the constructor or the initialize method. Let's take another look at the parent class. We could add our constructor to assign the 2 attributes, name and email, as so. Here I'm assigning the name argument to the name instance variable and the email argument to the email instance variable. Now let's say we also wanted to include providing the student number in the student class. We could override or extend the student's constructor. To do this, we would now define a constructor that has name, email, and student number attributes. We assign the student number instance variable from the student number argument, but because we've already created a constructor for the person class, we don't need to redefine it. We can simply call super with the name and email, and that will call a constructor inside the person superclass. I understand inheritance can be a difficult concept to grasp, so please take your time with this exercise. I'd like you to create a product class with price and quantity attributes. Then I'd like you to create a subclass, i.e. extend the product, with a wine class. The wine class should have variety and alcohol percent attributes in addition to the attributes that were defined in the product class. Even if you're having trouble with inheritance, please have a go at the exercise and we'll go through a solution in the next video.